Dear friends, welcome to my video. Kindly click on the CC button for subtitles. Let's dive into the fascinating world of quantum field theory, QFT, without getting bogged down with too many equations or technical jargon. Think of this as a friendly chat rather than a physics lecture. Quantum what now? QFT is the physics playground where quantum mechanics and special relativity come together for a playdate. It's like if you take the crazy behavior of tiny particles, quantum mechanics, and mix it with Einstein's ideas about the speed of light and time, relativity. It's an essential part of our understanding of the universe, especially at the smallest scales. Particles as fields. You know how a wave in the ocean isn't just one thing but a bunch of water molecules moving together. QFT says that particles like electrons and quarks, the stuff inside protons and neutrons, are kind of like that too. Instead of thinking of particles as little points zipping around, imagine them as waves in a field. This field is like a stretchy fabric that fills all of space. Imagine a trampoline surface, and how it bends and vibrates when you bounce on it. That's somewhat like these fields, but in many more dimensions. Waving hello to particles. So, what's a particle in this view? Imagine plucking a guitar string and watching it vibrate. That vibration is a wave in the string, right? Now, think of the string as one of these quantum fields, and the pluck as a particle. When you pluck the field, it vibrates in a specific way, and that's what we see as a particle. It's like a concentrated wave in the field. Interactions and forces. QFT isn't just about particles, it's also how they interact. You've probably heard of forces like gravity, electromagnetism, and the nuclear forces. In QFT, these forces come from the exchange of special particles called force carriers or bosons. For example, the electromagnetic force, the thing keeping you from falling through your chair right now, comes from the exchange of photons between charged particles. It's like two people on ice skates throwing a ball back and forth. They'd push each other away without ever touching, just like charged particles do with photons. The famous Higgs. Remember the Higgs boson? That's a part of QFT too. The Higgs field gives other particles mass, sort of like a cosmic syrup that particles have to move through. The more they interact with this field, the more mass they have, and the harder they are to move. Finding the Higgs boson was like finding a ripple in that cosmic syrup, proving it's real. Quantum loops and other headaches. QFT can get pretty wild, though. There are things like quantum loops, where particles temporarily split into other particles and then recombine. This leads to some mind-bending math and calculations, and it's one of the reasons why QFT is considered such a challenging field. But it's also one of its most enchanting aspects. Where does QFT take us? QFT has been essential in developing the Standard Model, which is the current best explanation we have for how all the fundamental particles and forces work together. Except gravity, it's still playing hard to get. From predicting particle behavior in colliders to explaining the early universe's conditions, QFT is a crucial tool in modern physics. It's like the Swiss Army knife of understanding the microscopic world. Wrapping up. So, there we have it. Quantum field theory is the framework that describes particles as fields, explains forces through particle exchanges, and even gives particles mass via the Higgs field. It might sound far-fetched, but it's been incredibly successful in explaining the universe at the smallest scales. QFT is still an active field of research, with many questions left to answer. But isn't that what makes science fun? The never-ending journey to uncover the mysteries of the universe, one quantum field at a time. Thank you for watching my video. Kindly subscribe to my YouTube channel and give a thumbs up. Thanks for your support.